Hi everyone, today we're going to talk about how to evaluate expressions. So let's start with our vocabulary. Evaluating expressions means that we're going to be utilizing our order of operations, which is a set of rules or steps we use to simplify expressions. Evaluate means to substitute for given values and then simplify. One of the operators that we use is called absolute value. Absolute value is the distance a number is from zero, and it's always positive. An algebraic expression is a math sentence with no equal sign that contains numbers, variables, and operators. A replacement value is a number that can be used to substitute for a given variable. Alright, so let's come down and talk about the actual order that we use when we evaluate problems. And we can use this acronym GEMDAS to help us remember. So G stands for our grouping symbols. So some examples of that can be parentheses, brackets, a square root symbol, the absolute value symbol, or a fraction bar. E is our exponent. An exponent tells you how many times to multiply a number by itself. So I could have something squared, I could have something, or I could have a number squared, so a variable squared or a number squared. M and D stand for multiplication and division. And when we have both of those in one problem, we work those operations from left to right. So we could see them written out this way. A dot between the two numbers. Sometimes we just have a number stuck to parentheses. Division, our division sign that we often see, or the fraction bar being used as the division sign. And then the A and the S stand for addition and subtraction. And once again, we work these two operations left to right. So just some examples of what addition and subtraction could look like in a problem. Alright, so let's come down and take a look at these two examples. So we're going to start with what's inside our grouping symbols, our 4 minus 2. So we're going to take care of that first, and then we'll bring everything else down. Remember, we want to work these out one step at a time. So when I do 4 minus 2, that gives me 2. And I bring everything else down, the negative 52. At this point, I also worked out the 8 squared, which is 64. And I brought down my 3. You're going to notice I kept my 2 inside parentheses because I had that squared and I still had this number sitting here, so which means 3 times 2 squared. Alright, my next step then is to do exponents. I really should have held off on this one to the next step, but just by habit it got done. Alright, so now we can do 2 squared. Before I can do 3 times 2, I have to do 2 squared first. We have to make sure we follow our order, and the exponents comes before multiplying. So 2 squared gives me 4. So now I have the problem, negative 52 plus 64 minus 3 times 4. Okay, now we can do multiplication, the next step. So 3 times 4 gives me 12. Everything else gets brought down. Now I have addition and subtraction. The order of operations tells me that when I have both of those operators, I work left to right. So the first thing I'm going to take care of is that addition. So negative 52 plus 64 gives me 12. And then bring down my minus 12. Finally, I can take care of that subtraction. 12 minus 12 is 0. And then I circle my answer. Alright, let's take a look at this problem here. So we can work this out, the top, and we can work out the bottom. We want to make sure that we work out the top fully and we work out the bottom fully, and then our last step will be to divide them. Alright, so the fraction bar counts as a grouping symbol, so let's take a look at what we have going on up top. Up top we have another set of grouping symbols, that absolute value, so I have to take care of what's inside first before I can find the absolute value. So first we're going to do negative 18 divided by 3. And that gives me negative 6. Notice I still have the absolute value symbols there. Okay. Now I can do that absolute value of negative 6. So that's the next thing I'm going to do, is take care of the absolute value. So the absolute value of negative 6 is a positive 6. You're going to notice I haven't touched the bottom yet. I'm going to do everything on top first, and then I'll start taking care of the bottom. So next I'm going to multiply. So actually I have multiplication in both the top and bottom. So we can do both of those at the same time. 6 times 2 is 12. 2 times 2 is 4. So I get 12 over 2 plus 4. All right, my next step then is I can take care of this addition, the 2 plus 4. So now I get 12 over 6, and then finally I can divide. 12 divided by 6 gives me 2. I'm done. I can circle my answer. All right, let's go to the next page. All right, I want you to take these two problems and I want you to try them on your own. Go ahead and pause the video now. Okay, let's take a look at example number 2. Waldo simplifies an expression as shown below. Find his error and then simplify the expression correctly. All right, so let's see what happened here. So, first thing, it looks like to get from here to here, the only thing I see that changed was this 3 squared became 9. So if we think back to our order of operations, GEMDAS, I look for grouping symbols. I don't have any. The E is exponents. Okay, so that seems to be right. All right, so the next thing that we're supposed to do is multiply. 8 times 2. We have subtraction, multiplication, and addition. So multiply is supposed to be next. It doesn't look like that's what happened though. It looks like they may have subtracted the 23 minus 8 instead of doing that 8 times 2. So we're going to say that that is where our error was made. Okay? Waldo subtracted before he multiplied. So let's come over here and let's solve the problem ourselves. So here's our original problem. And just like Waldo did, we're going to take care of the exponents first. So we're going to do the 3 squared to get 9. Now is where we're going to start fixing his mistake. The next step should have been 8 times 2, which is 16. Now we have subtraction and addition. Since we have those two operators, we can work them left to right. So we're going to take care of 23 minus 16. And then finally we can do that 7 plus 9. So the correct answer should have been 16. All right, I want you to come down here and I want you to take a look at what Michaela did. I want you to try and find her mistake, and then I want you to show the correct way to work out the problem. Go ahead and pause the video now. Okay, let's go to the next page. All right, so evaluating expressions. To evaluate an expression, first we need to substitute for the given values. And when we do that, we often will use parentheses. We're often going to put parentheses in when we substitute a number. We're going to use the order of operations then to simplify. All right, so let's take a look at this first problem. Evaluate the expression using the replacement values. X equals the square root of negative 5, or the absolute value of negative 5. Y equals 3 squared. And z equals the negative square root of 16. Well, those look awfully complicated, so why don't we try and simplify those down a little bit. So the absolute value of negative 5 is actually 5. So for x, instead of substituting in the absolute value of negative 5, we're just going to substitute in 5. For y equals 3 squared, well, 3 squared actually has a value of 9. So for y, we'll actually substitute in the value 9. And then z equals the negative square root of 16. Well, we know that the square root of 16 is 4, so the negative square root of 16 would be negative 4. All right, so those are the 3 actual values that we're going to substitute in. All right, so when we go to substitute them in, Okay? We're going to use parentheses. Whenever we substitute in a value, we use parentheses. We're going to notice that that subtraction sign between the y and z is going to stay there when I substitute. And then we're going to carry over that negative sign with the 4 because that's part of the value we're substituting in. All right, now we can use our order of operations. Order of operations says that we have to multiply first. So I'm going to take care of that 5 times 9 first. We get 45. All right, so now I can take care of the 45 minus negative 4. Right? So if I put that in my calculator, or I can change this to two negatives make a positive, it's really saying 45 plus 4. So I get 49. Right, now I can take care of the bottom. 2 times 5 is 10. So now we have 49 over 10. And if we divide that, we end up with 4.9. Then we can circle our answer. All right, let's try this one here, where we have an absolute value problem. Again, we're going to use these 3 simplified values. All right, so I'm going to substitute 2 times 5 plus 9, and then in parentheses, negative 4. All right, so now I can take care of the 2 times 5, and that's 10. I still have the absolute value symbols there because I haven't actually done that operator yet. Now we can do the absolute value of 10, which is positive 10. Now I have addition and multiplication. So we're going to take care of that multiplication first. So 9 times negative 4 give me negative 36. 10 plus negative 36 will give us a negative 26. Circle our answer. All right, I want you to come down here, and I want you to try these two on your own. Simplify these values when possible. Go ahead and pause the video now. All right, let's come down here and take a look at these next two problems. So same type of thing. We're going to evaluate the expression using the replacement values for x equals 16, y equals negative 1, and z equals negative 3. So when I look at these values, I don't need to do any simplifying with them first. They're ready to go. All right, so let's go ahead and substitute them in. Okay, so again, I use parentheses when I substitute it in. We're going to notice my exponent is sitting on the outside. All right, so GEMDAS, our order of operations, tells us to take care of grouping symbols first. Well, inside my parentheses, I only have a 16. There's nothing to do. And inside this set of parentheses, I only have a negative 3. Again, nothing that I can do. So now I can move on to exponents. So I need to do negative 3 to the second power. That's saying negative 3 times negative 3. Two negatives will make a positive. So that will end up giving me a 9, a positive 9. And this subtraction sign here is because of this one that got brought down. All right, so now we can take care of multiplication. I've got multiplication and then subtraction. All right, well, 1/2 times 16. We should be able to figure out what 1/2 of 16 is. If I were to take 16 and split it in half, I'd get 8. So now I'm left with 8 minus 9. Okay, well, 8 minus 9 gives us a negative 1. And then I can circle my answer. All right, let's try one more. All right, we have the absolute value of 6 times z plus the square root of x minus y times z. All right, we have to be really careful when we simplify here. Notice that my square root symbol ends at just the x. That minus yz is not underneath the square root symbol. Okay, so we have to make sure we pay attention to that when we substitute. So when I substitute in, notice my square root symbol stops at the end of 16. None of the other stuff is included. Okay, so now let's take care of grouping symbols inside my absolute values. I can do negative 6 times 3 gives me negative 18. I still have the absolute value symbols because I have not actually performed that operation yet. Now we can take the absolute value of negative 18, and that gives me a positive 18. Right now, I have this grouping symbol here, right, my square root symbol, so we can take care of that next. So the square root of 16 is 4. So now I've got 18 plus 4 minus negative 1 times negative 3. I've got addition, subtraction, multiplication. Multiplication is what comes next. So negative 1 times negative 3 gives me a positive 3. And then I'll bring everything else down. Now we can take care of the addition and then the subtraction. 18 plus 4 is 22, minus 3 gives us a final answer of 19. Circle our answer. All right, I want you to take a look at these last two problems, and then that will be it. So complete these last two problems before next class, and I will see you the next time we have class.